Hey everyone, and welcome back. Today we're going to be diving into the world of AI,
Oh, yeah.
specifically something called Large Vision Language Models, or LVLMs.
Okay.
And you might be interested in this deep dive if you work with AI,
Mm-hmm.
are fascinated by how these language models think, or even if you just love quirky tech facts. So
Right.
basically, these LVLMs are AI models that can understand images and generate text descriptions of them.
Yeah.
So think of image captioning apps or AI assistants that can answer questions about a photo.
Mm-hmm.
That's LVLMs in action.
I see.
And our main source today is a research paper titled The Hidden Life of Tokens: Reducing Hallucination of Large Vision Language Models via Visual Information Steering.
It's a fascinating paper
Yeah.
because it tackles a really interesting quirk of these LVLMs.
Okay.
Sometimes they generate text that, while it is grammatically correct,
Yeah.
doesn't actually match what's in the image.
So what do you mean by that?
Like, imagine you show a picture of a dog to an LVLM, and it captions it as a cat sitting on a couch.
Okay.
That's what the researchers refer to as hallucination.
So the AI is kind of like making things up?
Yeah?
That's a little unnerving.
Yeah, it can be.
I mean, what are the real-world implications of this?
That's a great question.
Yeah.
And it's one of the researchers explored.
Okay.
Imagine an AI assistant for visually impaired people, for example.
Right.
If it starts hallucinating, describing things that aren't there,
Yeah.
it could have some pretty serious consequences.
Yeah, that's a really good point.
hmm
So how did the researchers get to the bottom of why these LVLMs hallucinate?
Well, they used a new method called token ranking analysis
Okay.
to understand how these models process information.
Token ranking analysis. Can you break that down for us?
Sure.
What exactly are tokens in this context?
So think of tokens as the building blocks of language.
Okay.
They can be words,
Mm-hmm.
parts of words,
Mm-hmm.
or even punctuation marks.
Gotcha.
Token ranking analysis essentially tracks how the AI prioritizes these different tokens as it generates a text description of an image.
So it's like figuring out which words the AI is most likely to pick.
Exactly.
Okay.
It's kind of like those popularity contests.
Uh-huh.
The most popular words are at the front of the line.
Gotcha.
And by looking at these rankings, the researchers categorize tokens into three types.
Okay.
Decoded genuine tokens,
Okay.
which are the words that accurately describe what's in the image.
Mm-hmm.
Hidden genuine tokens,
Okay.
which are details the AI seems to recognize but doesn't say out loud.
Interesting.
And hallucinated tokens, which are the made-up words that don't have any visual basis in the picture.
So there's 3 different types of tokens.
That's right.
That's really clever.
Thanks.
So what did they learn from this whole token ranking analysis?
Well-
Did they find anything surprising?
They had 3 key observations,
Okay.
each more intriguing than the last.
Right, I'm ready.
The first one they called gradual visual information loss.
Okay, gradual visual information loss.
Yeah,
Sounds pretty ominous.
it does.
What does that even mean?
It means that as the LVLM generates longer captions,
Okay.
it starts to rely more on its internal language patterns
Mm-hmm.
and less on what's actually in the image.
So the AI is kind of like losing its focus on the picture as it goes on.
Right.
Like it starts off strong, but then it gets lost in its own words.
That's a great way to put it.
Okay.
The researchers compare it to a game of telephone,
Yeah,
where the message gets distorted as it's passed along.
right. I can see that.
Yeah.
What about the other 2 observations? What did the researchers find?
The second observation, called early excitation,
Okay.
is where things get really interesting.
Right.
They found that sometimes the model actually has the right words in mind early on in the process,
Mm-hmm.
but then, for some reason, it drops them in the final output.
Wait, seriously?
Yeah.
It's like the AI has a moment of clarity and then just forgets.
It's strange, isn't it?
That's so bizarre.
I know.
And then the third observation,
Yes.
hidden genuine information,
Uh-huh.
is equally fascinating.
It is.
It suggests that the AI model might actually be recognizing more detail in the image than it lets on.
Right.
So it's picking up on things but not actually telling us.
Exactly.
Like it's keeping secrets.
You could say that.
What's that all about?
It's definitely intriguing, right?
Yeah.
The analysis showed that the model sometimes recognizes things in the image, but chooses not to include them in the description.
Huh.
It's like it's subconsciously aware of them, but doesn't actively register them.
That is so wild.
Yeah.
Okay, so we've established that these LVLMs have some quirks.
A few quirks.
To put it mildly.
Yeah.
But what can be done about it?
Well,
Did the researchers come up with any solutions to this hallucination problem?
they did. They developed a framework called VISTA,
VISTA.
which stands for Visual Information Steering with Token Logic Augmentation,
Okay.
to try and make these LVLMs more accurate and reliable.
VISTA. Okay. I'm intrigued. How does it actually work?
Well,
Is it some kind of complex retraining process?
it's actually surprisingly elegant.
Okay.
VISTA has 2 core modules,
Okay.
a visual steering vector, or VSV,
Okay.
and a self-logits augmentation, or SLA.
So the VSV and SLA are the dynamic duo working to keep these LVLMs in check.
You could say that.
Okay.
Think of the VSV as a gentle nudge to keep the age in mind.
Okay.
During the caption generation process,
Mm-hmm.
it's constantly reminding the AI to stay focused on those visual cues.
That makes sense. And what about SLA? What role does that play?
So remember how we talked about the AI sometimes having the right words in mind early on,
Yeah.
but then discarding them?
Right, right.
Well, SLA is like a booster for those early signals.
Uh-huh.
It amplifies the importance of those potentially meaningful words,
Okay.
so they're more likely to make it into the final caption.
So it's like giving those almost forgotten words a second chance.
Exactly.
Okay.
And what's really cool is that VISTA doesn't require retraining the entire model.
Oh, wow.
It can be applied during the caption generation process.
So it's very efficient.
Yeah, making it incredibly practical and efficient.
Okay, so VISTA sounds great in theory.
Yeah.
But did it actually work? Did it really reduce those hallucinations?
That's where the rubber meets the road, right?
Yeah.
And the results were really impressive.
Okay.
They tested VISTA on several popular LVLMs.
Uh-huh.
Ones you might have even heard of, like Alava,
Okay.
Shikra-MIDI GPT-4, and InstructBlip.
Wow.
And across the board, it significantly reduced the number of hallucinations.
That's great to hear.
Yeah.
So VISTA actually made these models more accurate.
Not only more accurate,
Okay.
but also more detailed.
Interesting.
The captions became richer and more true to the image, without those pesky made-up details.
That's amazing. Could you maybe walk us through a specific example?
Sure.
So we can really see VISTA in action?
Absolutely. Let's look at an example from the paper.
Okay.
They used a picture of a baseball game.
Mm-hmm.
A classic summer day at the ballpark. There's a young day at home plate, bat in hand, ready to hit the ball.
Okay.
There are spectators in the stands, all watching intently.
Okay, I can picture it. What did the LVLM say about this image?
Well, one of the models, without VISTA, described the scene pretty well,
Okay.
but mentioned several chairs placed around the field.
Okay.
The problem is there are no chairs in the image at all.
Ah, there's that hallucination again.
Right.
Those phantom chairs.
Exactly.
So what happened when they applied VISTA? Did it get rid of the chairs?
It did.
Okay.
With VISTA enabled the model accurately describe the scene,
Oh, right.
even picking up on subtle details like benches, handbags, and hats that the original caption missed,
Okay.
and no mention of chairs.
Wow, so VISTA not only eliminated the hallucination, but also made the caption more detailed and accurate.
Uh-huh.
That's incredible.
It's a really promising approach.
Yeah.
And it highlights how much progress is being made in addressing these limitations.
This whole deep dive has been so fascinating.
Yeah.
We've gone from understanding how LVLMs process information to seeing how they can hallucinate
Right.
to learning about a potential solution.
Yeah.
It's really mind-blowing.
And it really makes you think, doesn't it?
It does.
If AI models are already capable of recognizing information they don't explicitly state,
Right.
like those hidden genuine tokens we talked about,
Uh-huh.
what does that say about the potential for even more complex and nuanced AI systems in the future?
That's a really good question. What could these future AI systems be capable of? It really makes you think, right?
It does.
If these models are already picking up on details they don't explicitly mention,
Right.
what's next?
Yeah, what other hidden layers are there waiting to be explored?
Yeah, I mean,
We're already seeing such rapid advancements in this field.
I know, it's crazy.
Who knows what's just around the corner?
Yeah, like what?
Maybe AI that can not only understand and describe images,
Uh-huh.
but also make inferences
Okay.
and predictions about the future based on what they see.
Like AI that can predict what's going to happen next in a video
Yeah,
just by analyzing a single frame?
exactly.
That would be incredible.
It would.
And a little bit spooky, too.
Definitely.
Yeah,
There's always that balance to consider,
right.
the incredible potential of these technologies,
Yeah,
alongside the ethical considerations and potential risks.
for sure. For sure. But for now, I
Yeah.
think we've covered a lot of ground in this deep dive.
We have.
We've learned about LVLMs, their tendency to hallucinate,
Mm-hmm.
and even a potential solution to that problem with VISTA.
Right.
It's been a wild ride.
It has. And hopefully our listeners have a better understanding now
Yeah.
of how these models work, what their limitations are,
Uh-huh.
and why it's so important to keep exploring and refining them.
Absolutely. I think this deep dive has definitely given us a lot to think about.
Yeah.
What are your final thoughts for our listeners today?
I'd say stay curious.
Okay,
This field is evolving so quickly, and there's always something new to learn.
that's true.
Keep asking questions, keep exploring, and who knows,
Yeah.
maybe you'll be the one to make the next groundbreaking discovery in the world of AI.
Well said. And thanks to all of you for joining us on this deep dive into the hidden life of tokens.
Yes, thank you.
Until next time, keep exploring and stay curious.
2T511.